Hello students, in this class we are going to learn about types of functions. So first of all, we'll see that we have already seen what is function, what is the difference between function and relation, and what is domain, what is codomain, what is range. We are already familiar with all these concepts. So now we are going to see the different type of functions. First of all, we'll see that identity function. So the function f is a function from R to R, correct? Where R is a set of real numbers. So first type is identity function. The function f is a function from R to R, where R is a set of real numbers. Okay. So the function f the function f means f is a function from R to R defined by y is equal to fx is equal to x, where x is a member of real number is called the identity function. Means here y is equal to x. We write y is equal to fx, isn't it? Y is a function of x. So here in this case, y is equal to x. It means what? If x is equal to 1, y is also 1. If x is equal to 2, y is also 2. If x is equal to 3, y is also 3. If x is equal to minus 4, y is also minus 4. Correct? So when we will plot these points on a graph, this is your x-axis, this is your y-axis. Y-axis means f of x-axis. So we'll get a line like this. It's a straight line passing through the origin. So what is the domain here? Domain of identity function is what? Domain of identity function is set of real numbers. What is the range? Range is also the set of real numbers. And the graph is a straight line. It passes through the origin. So this is the first type of function. Now we are going to see the second function. This is constant function. Function f. F is a function from R to R. Again here R is a set of real numbers. It's a real number set. Then f is a function from R to R defined by y is equal to fx is equal to c, where c is a constant, where x is a member of, x is an element of real number set, where c is a constant is called constant. So the function f from R to R defined by y is equal to fx is equal to c, where x is a member of real number and c is a constant. So this is called a constant function. So what when we will plot the graph of this, means here y is equal to what? C. C is any real number, means y is equal to 2 or y is equal to 3. So in this graph, we have taken this y is equal to 3. So what will be the graph of y is equal to 3? This is the graph, this blue line. Y is equal to 3 means what? For any value of x, what is the value of y? 3. Means for any value of x, the value of y is constant, that is equal to 3. That is why it is called constant function. So this is a constant function, and this is a straight line parallel to x-axis. So what will be its domain? Its domain will be set of real numbers. And what will be its range? Its range will be, means what is the value of y? Y is only 3. So range will be only c. Here in this case, it is 3 because 2, 3, 4, 5, 6 like it is there. So domain is equal to set of real numbers and range is equal to c, that constant. Here in this case, it is equal to y is equal to 3. So range is equal to only one single number, that is 3. Okay. The graph is a line parallel to x-axis. Yes, you already seen it. Now come to the third type. Third type is a polynomial function. F is a function from R to R, where R is a set of real numbers, defined by fx is equal to a0 plus a1x plus a2x square plus anx to the power n, where n is a non-negative integer. It means what? this n, the power of n, this n cannot be negative. N cannot be negative number. Negative number or negative number or negative integer. Integer means what? It cannot be fraction. Means x to the power minus 2 not allowed. X to the power minus 3 not allowed. Means it should be only positive integer. Means x to the power 1, x to the power 5, x to the power 7, x to the power 100. Okay, only positive power of x is allowed. And the fraction is also not allowed because it is non-negative integer. Means only integer should be there. Correct? Fraction is not, I mean, you cannot write like that x to the power 2 by 3. No, it is not allowed. So that will not remain as a polynomial. So if it is a polynomial, then the form of the polynomial is f of x is equal to a0 plus a1x plus a2x square plus an x to the power n, where n is a non-negative integer. Remember, non-negative integer. N should not be negative and n should not be a fraction. This is called a polynomial function. So when the maximum power of n, when maximum power of x, means when the x is equal to maximum power of x is equal to n, where when n is equal to 1, then it becomes a linear function. In this case, x to the power n means here n is equal to 1. So it becomes x plus b. This is called a linear function. When it is x to the power n, when n is equal to 2, it becomes a quadratic function. Correct? And where a, b, and c are member of real numbers. And when x to the power n, when n is equal to 3, it becomes a cubic function. Cubic function. When n is equal to 3, this is a quadratic function. Correct? So now the graph of some polynomial functions. Polynomial function means when the graph is like this, y is equal to ax plus b. So this is linear function. Why linear? Because this represents a equation of line. This represents the equation of a straight line. That is why it is called a linear function. Correct? So now here, just see there is a example. One example is given. F of x is equal to x plus 10. What is fx? Means y. It means y is equal to x plus 10. Now see here. In this type of graph, if you want to draw this type of graphs, then no need to take more than 2 points. Only 2 points are sufficient. Correct? If your equation is like this, y is equal to, this is y is equal to x plus 10, then make this table. This is x, this is y. So when x is equal to 0, then y is equal to what? 10. And when y is equal to 0, when this y becomes 0, in that case, x plus 10 is equal to 0, means x is equal to minus 10. So when y is equal to 0, x is equal to minus 10. So only 2 points are sufficient to draw the graph of this function. So see here, what is the first point? 0, 10. 0, 10 is this point. What is the second point? Minus 10 and 0. Means first coordinate is, x coordinate is minus 10, y coordinate is 0. Minus 10, 0. Now you connect this line, you will get the graph of this line. But this is also a straight line. Correct? And this is called in this type of, this is called your y-intercept. This is called y-intercept. And this is called x-intercept. X-intercept. Correct? So this is one type of function, linear function. Now come to the fourth type, that is quadratic function. When the graph is of this form, fx is equal to x squared. So what is the maximum power of x here? 2. The n is equal to 2. It means what? Quadratic function. Quadratic function. Correct? So we have already seen it in the physics also. So what will be the graph? What the graph? What will be the nature of graph of quadratic function? How it will look like? It will look like a parabola. Means here y is equal to x square. Means if x is equal to 1, then y is equal to also 1. When x is equal to minus 1, then also y is equal to 1. When x is equal to 2, then y is equal to 4. And when x is equal to minus 2, then also y is equal to 4. Isn't it? So when you will draw the graph of this, you will get a graph like this. Y is equal to x square. Means for a single y, there are two values of x. See here, if it is 4, it means it can be minus 2. Here the x will be minus 2. X is equal to minus 2. And here the x will be plus 2 also. Correct? If here it is 9, just imagine that it is 9. If it is 9, then here it will be minus 3. And here it will be x is equal to minus 3. And x is equal to plus 3. Are you getting? So you will get a graph like this. This is called parabola. So the graph of a quadratic function is a parabola. Now cubic function. Cubic function means here y is equal to x to the power cube. Y is equal to fx is equal to x to the power cube, where x is a member of real number. X is an element of real number set. So when you will draw the graph of this, you will find a graph like this. Means just see, if you are putting x is equal to 1, you are getting y is equal to also 1 to the power cube is equal to 1. When you are putting x is equal to minus 1, then you are getting y is equal to minus 1 to the power cube, that is minus 1. Correct? When you are putting x is equal to plus 2, you are getting y is equal to x to the power cube, means 2 to the power cube, that is 8. When you are putting x is equal to minus 2, then y is equal to minus 2 to the power cube, that is minus 8. Correct? So you will for all the positive values, you will get a graph like this. For negative values, you will get a graph like this. So this is the graph of a cubic function. Now rational function. So a function f from R to R is said to be rational function if the function fx is of the form gx upon hx. Means it is the ratio of two functions. It is a ratio of two functions. So that is, it is called rational function, where gx and hx are polynomial functions of x and where hx is not equal to 0. Correct? Because if hx becomes 0, then your fx becomes g of x upon 0, which is not defined. Now your function becomes undefined. So hx should not be equal to 0. Correct? This is the condition where hx should not be equal to. So see here there is an example. F of x is equal to x plus 3 upon x minus 4. That also you can write like this. Y is equal to f of x is equal to x plus 3 upon x minus 4. So if x minus 4 becomes 0, then this expression becomes, then y becomes x plus 3 upon 0, means it becomes, function becomes undefined. So x minus 4 is equal to 0 is not allowed. So x minus 4 should not be equal to 0. It means x should not be equal to 4. So this is the condition. So what will be the domain of this? Domain of this will be all the real number set and except x is equal to 4. Domain will be all the real values of x except x is equal to 4. And what will be the y? Y will be it's a set of real number. Now the modulus function. Modulus function, we already know that modulus function means mod of x. So if x is equal to 5, then also when you will take the mod, it is positive. It will remain positive only. When x is equal to minus 5, then also when we are taking the modulus, then mod of x means mod of minus 5 is equal to what? 5. Means we are taking only positive values. This is the meaning of mod. So how it is defined? Just see here. So f is a function from R to R defined by fx is equal to mod of x. For each x is a member of real number. So when the modulus function is defined like this, when x is greater than or equal to 0, then fx is equal to x. And when fx is less than 0, in that case, fx is equal to minus x. Means just imagine that if x is equal to 2, then simply you can write mod of x is equal to what? 2 only. Isn't it? But if x is equal to minus 2, then you will have to write, then in that case, fx is equal to minus x, means minus of minus 2. So minus of minus 2 is what? That is plus 2. So that is why we are taking all the positive values here, whether the x is negative or positive. When x is greater than or equal to 0, then there is no change. But when it is x is less than 0, in that case, it will be minus 2. Then you will take the minus of that, means minus minus 2. It will become plus. So in this way, we have defined the modulus function. So what is the domain of this function? Domain of this all the real number set. And what will be the range? Range means what? After applying this function, what you are getting? Only positive numbers. Okay. So it will. So it means our range will vary from 0 to infinity. 0 to infinity. And the graph of modulus function will be like this. See here. Graph of modulus function will be like this. When x is equal to minus 2, what will take? Will take 2. Y is equal to 2. When x is equal to 2, then there is no problem. It is 2 only. When x is equal to minus 4, then also we will take the only positive value. So y will be plus 4. When it's equal to plus 4, there is no change. It is plus 4 only. Correct? So our graph will be like this. Correct? So this is called modulus function. And this expression is very important. Means f of x is equal to x if x is greater than or equal to 0. And f of x is equal to minus x if x is less than 0. If it is negative, then you take the negative of it. Means if it is minus 2, then minus of minus 2, that is plus 2. Now Signum function. So this is a function f from R to R, where R is the set of real numbers. So here fx, when x is greater than 0, when x is greater than 0, y is equal to 1. And when x is equal to 0, y is equal to 0. And when x is equal to less than 0, y is equal to minus 1. Means if you are taking x is equal to 5, then what you will write? In that case, y is equal to 1. When x is equal to 112, what is y? Y is equal to 1. Correct? And when x is equal to 0, in that case, y is also 0. And when x is equal to minus 5, then y is equal to minus 1. When x is equal to minus 95, then also y is equal to minus 1. Means here the range is having only 3 values, 1, 0, and minus 1. And domain can be any real number. So domain is equal to, domain of a Signum function is real number set, and the range of Signum function is minus 1, 0, and 1. When the x is less than 0, then it will be minus 1, y is equal to minus 1. When x is equal to 0, then y is equal to 0. When x is greater than 0, any number it may be, 1050, 2222, then also the y will be 1 only. Okay, so range is equal to minus 1, 0, 1. It means here when you will draw this graph for Signum function, you will get this. This is a dot. This is a closed dot. Means solid dot. Means this will be when x is equal to 0, y is equal to 0. When x is equal to 5, then y is equal to 1. Y is equal to 1. Take any value. Take any value for x. It will be y is equal to 1. And take any value of negative value. Take any value for x is negative, then you will get y is equal to -1. Correct? So this arrow represents that it can be any positive value, the y is equal to 1. It is any negative value, the y is equal to -1. So range domain is equal to set of real numbers, and range is equal to -1, 0, and 1. Only 3. Now come to the next one. Next one is the greatest integer function. So this is a function f from R to R, where R is the set of real numbers defined by f of x is equal to x. Here we represent greatest integer function by this, means in a square bracket. Y is equal to x in a square bracket means what? A square bracket x means this shows that this is a greatest integer function. This shows that this is greatest integer function. Correct? So here this in a square bracket x denotes the greatest integer less than or equal to x. What does it mean? It means we have defined greatest integer function like this. If greatest integer function denotes the greatest integer less than or equal to x, means if number is 2.8, then 2.1 is not a integer. So what is the less integer, the integer which is less than this? 2. So answer will be 2. So y is equal to 2. And here see also, if the number is minus 2.8, here again you have to take the, what is the less integer than this? Minus 2.8, minus 3. Minus 3 is less than this. So minus 3. You have to take the greatest integer, means whatever number is written in the bracket, you take the less integer. Here 2.8. So answer will be, it will not be 3, it will be 2. Less than 2.8. It is minus 2.8. It will not, it will be minus 3, because minus 3 is less than minus 2.8. Correct? So in this way we have defined the greatest integer function. Means if it is 5.1, then what will be the value? Y will be 5. If it is 7.5 minus, what will be the value? It will be -8. Correct? Because less than this. -8 is less than this. -8 is an integer which is less than -7.5. Here 5.1, 5 is an integer which is less than 5.1. So the graph will be like this. See here, like this. So in this way, we have covered in this class different type of functions. Correct? Now in next class we'll learn some more like inverse functions, composite functions, like that. Okay. So for today we'll stop here.